We talked a few moments ago about an angle of elevation, and now we're going to look at an angle of depression. Now, when we're talking about these angles of elevation and angles of depression, we're talking about line of sight to something either up or down. A line of sight up is an angle of elevation. An angle of sight looking down is an angle of depression. But let's read through our problem here. It says a lifeguard is watching a beach from a line of sight at 6 feet above the ground. And let's go ahead and let's just draw us a line right here. And this is 6 feet. So the lifeguard, she's 6 feet off the ground, and she is looking at a swimmer out in the ocean, lake, whatever, the water, at an angle of depression of 8. And so we're considering this horizontal line if she was looking straight ahead. And what is the angle at which she's looking down at this swimmer? And this is given to us as an 8-degree angle. Now, here's the swimmer out in the water. Now, at the same time, there is another horizontal line that's running from this swimmer that we don't have defined, let's say, and it's running to the ground. It's not a straight line, but hey, you can live with it. Now, if I think about this, I've got two horizontal lines. If one is going straight from the sight of the lifeguard looking straight ahead, and then from the swimmer who's in the water looking to the base of the or to the ground here, we've got two horizontal lines. And this line of sight, the black line here, from the lifeguard down to the swimmer, we could consider that as a transversal between two parallel lines. Now, if that's the case, is there a relationship between this angle and this angle here? And you might recall something called alternate interior angles, the alternate interior angle theorem. And so if the line of depression is 8%, then the angle from that line of sight to the swimmer, then back to the base of the tower, well, it's also going to be 8%. I mean, 8 degree, not percent. 8 degree, 8 degree, 8 degree. Now, this from where the line that we drew from the lifeguard to the ground, and from the swimmer, this horizontal line from the swimmer to the base of the tower, well, look, that happens to form a right angle. And guess what we're getting ready to use? Right angle trigonometry. And so again, I want to write up here SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Now let's consider what we know. Okay, we have determined an angle, and opposite that angle, we've got a measure of 6 feet from the lifeguard at the top of the tower down to the ground. And what are we trying to find? How far away is from the tower is the swimmer? So we're trying to find the measure of that distance from the swimmer to the tower. All right, well, opposite, adjacent, opposite, adjacent. And I think I could use a tangent function to solve this. So let's see here. We got a tangent of 8 degrees, and it's equal to the opposite, which we know is 6 feet, over the adjacent, which we do not know, and let's just call that x. Now, if I multiply both sides of this equation by x to clear out that denominator, well, then I got x times the tan of 8 equals 6. And then x is going to equal 6 times the tangent of 8. 6, did I say times? No, not times, divide. 6 divided by the tangent of 8. 6 divided by the tangent of 8. And we're going to round this thing to the nearest foot. So I got 6 divided by tangent of 8, hit enter. I got 42.69. So we're going to say that this is approximately equal to 43 feet. It's probably good for this lifeguard to know how far this guy is. This guy may or may not know he's 43 feet away from the shore. Lifeguard sure needs to know, because she'd have to jump out and swim that 43 feet and bring him back if he should get into distress. Shazam.